you so much for coming here today. You guys are about to be wowed. These 5 young innovators. They are developing solutions for challenges that we face today. So our first presenter, she is a grade 10 student from Prince Rupert who is creating an innovative solution for capturing renewable energy from an unexpected source. Please welcome Aaliyah to the stage. Aaliyah?
Hello everyone, thank you so much. I'm so excited to have this opportunity today to share with you an exciting innovation that I've been working on for the past 3 years. What if I told you that we could set up a system that would allow us to harvest electricity from bacteria? Well, the process is called microbial film power generation, and it works like this. Basically, 2 graphite plates are inserted into the soil, one at surface level and one below surface level where there's no oxygen. Between these 2 plates, billions of bacteria are doing what bacteria do best. They're decomposing the organic matter. Now let me explain a bit more about what's actually happening in terms of the chemistry. When microbes decompose, they actually produce energized electrons. Now in this case, I'm using graphite plates to capture these electrons and put them to use. Because the bottom plate has no oxygen, the electrons don't react and form water. Instead, they can be captured. In this case, they're being captured and put to use in low-powered devices and or to charge a battery. So let me talk to you about the second year of my research. In the second year of my R&D, I decided to switch out some things. So basically, I switched out the solid graphite plates for graphite felt, and I produced 38 times more power using this material. I also found out that with a continuous load, the system can actually charge an object for 2 days. At 2 days, the system fully exhausts. But what I also found out is that if you take it apart and just leave it for 1 day, it can actually naturally recharge, which is super interesting. So this here is a picture of my setup. As you can see, it looks quite simple and straightforward. It's so simple, in fact, that you could just set it up in your backyard. Now, I specifically, though, was setting this up with a different goal in mind, for scientific data collection. For example, under forest canopy or on the ocean floor where there's little light, this system could be extremely useful. This is just a little video of the potential it has. Basically, using 3 buckets of earth, 3 buckets of muskeg, I was able to power a buzzer. So I think that microbial film power generation has a really big future in terms of environmental science. I think that it has a great place next to its relatives solar energy, wind energy, and hydroelectric power. A novel use for this might be to put it and take the concept and apply it to sewage treatment plants where there's fermentation happening constantly and therefore lots of energy to be collected. Thank you so much. I now open the floor to questions.
Great. That was a fabulous presentation. Thank you very much. I'm just wondering if you could give us an example of something that you have powered with this type of energy.
Okay, great. So what I've powered successfully is a calculator, a buzzer, and an LED. These are just 3 low-powered devices that I was able to run, but the potential there's so much more potential with this project, I think. But really, this is for taking the weight off using fossil fuels for low-powered devices, and instead using this. And really, as I said, it's also for data collection, I would say. Yeah.
And ultimately, how do you think this could be scaled up?
Well, I definitely think that, as I said, fossil fuels are being used to run low-powered devices when we could be using microbial film power generation instead. Also, as I was talking about the waste in sewage treatment plants, this is all our waste, and there's so much energy that could be collected from that. So if I were to scale it up, I would say, let's stick a whole bunch of graphite in the sewage treatment plant and collect a whole bunch of energy.
Great. Thank you very much.
Yeah, thank you.
Thank you, Aaliyah. Thank you so much.